Okay, so we're ready to go on to some other stuff, and we're going to do some. They changed my. Stop that. They changed my version on me. So what we're going to do is talk about covariance. Covariance. And what we're going to do is talk about the different versions in that. And so we're going to start out with z is a function of x and y. So our response is a function of longitude and latitude. And my dog is eating. You can hear that. That's all right. So what we do in this case is going to look for the relationship between the z's at different longitudes and latitudes. So we have what's called the empirical versions. So those are the actual versions. So, and that is also between the x's and the y's themselves. So that's going to be x1 minus x2 times x, sorry, I didn't mean to change color on you, x1 minus x2, and divided by 2 and so on. All right, and then what I want to do is have a theoretical one. Theoretical version. Okay? Now, what we do when you're doing this on the computer, when you're doing it very elaborately, you plot the empirical one, and then you plot a line version that is the theoretical version, and there are 15 theoretical ones to choose from, and you decide which one is the best. Okay? And once you decide which one is the best, that is the theoretical model that you choose. All right. So what we do, we have special names for some of the things in these values. For instance, the closest value to 0 that our empirical value gets closest to 0 on the y-axis, closest to 0, sorry about the crappy pen. That's called the nugget. Wait, let me see if I can fix something. Nugget. That's better. Okay? Then at some point in time, your line is going to hit a maximum and level out. At the horizontal value, not vertical, horizontal value of max is, oops, sorry, where's my eraser? Here it is. Is the sill. And then the vertical value, the actual vertical value itself, vertical value, I'm sorry, I did that backwards. The vertical value is the range. Stop that. And then the vertical value is the sill. There. See, they have special names. Okay? Good. All right. Now, so once we get our nugget, and sometimes the nugget's 0, don't worry about that. So you get your nugget, you get your sill, you get your range, and you get the kind of model. Okay, and what I've been using, there's a package called AutoMap, and you'll see this. Oh, because I'm touching it. Sorry. There's a package called AutoMap, and it actually selects the model for us. So that's what I've been using. I know that's cheating. You should really use it by hand. And instead of selecting from the 15 models, it selects from 4. Well, close enough for rock and roll. Okay? So once we have that, then we have our theoretical, what's called the semi-variogram. That gives us our covariance. Actually, our covariance divided by 2. That's our semi-variance. Okay? So then what we're going to do, we're working on what's called ordinary Kriging. And this is very exciting. And I know you're saying, no, it's not. It sucks. It does not suck. And there's 2 particular steps that we have to do. All right? One is you have to find the spatial mean. But that's just not the mean of the observation. It's not equal to the average of the z's. No. That would be too simple. But it's very easy. It is, and now notice, in statistics, when you have an estimate, things wear hats. Okay, so the spatial mean is mu hat, And it's going to be, and I lied to you the other day, I put the things wrong. So this is, that's my phone, don't worry about it. The dog stopped chewing. C inverse times Z. Okay? So this is 1 prime. So that's a list of ones times C, that's your semivariance matrix inverse, times another list of ones, but that is not transpose anymore. And then that whole thing inverse times 1 inverse times C inverse times Z. Well, first of all, so these are what we call quadratic forms. First of all, do not worry about this. Everything you see here is going to be done with the computer. But this is just what's going on. This is what's being computed. This is the spatial mean. Okay? This is very beautiful. All right? And let's see if I can make the page scoot up a little bit. Can I do that? No. Then the next thing that we have to do is do predictions. So we already have our mean. Okay. And I'm pulling the oops. I'm trying to get the mean off the other computer. Don't go anywhere. Here it is. Okay. That's an I. So, the prediction, I'm going to call that Z hat of OK, that just means ordinary Krige, is, there's your spatial mean. This is just if I'm going to predict one thing, plus C prime 0. That's at that particular point. C inverse, because you have to give it the point that you're predicting at. That would be the longitude and latitude, times Z minus mu, and then your ones. Very simple. Okay? Isn't that beautiful? All right. So the tricky part is really that which is on the previous page, getting the spatial mean. Once we have that, everything else is done. Okay? Hope you like that. And we're going to have an assignment pretty soon. All right? Thanks.